Hello, I will explain my paper in this video. My paper about personalized metabolic analysis of diseases in different flux types. And we based our study in the metabolics algorithm. The metabolics algorithm aim to classify diseases, patient and healthy individuals. And we focus breast cancer patients at this work. We have a breast cancer data set, and in the data set we have 227 different reactions. We calculate 10,600 reaction differences and 98 pathways, and we classify. We use them like a feature, and we classify. We create a classification, supervised classification model. And to achieve this, we create a pipeline. Our pipeline has 8 steps. First steps, it's splitting data to get cross-validation performance scores. And second step is scaling reactions by standard scaler. And third step is applying flux analysis such as PFBA and FBA. And 4 steps, calculating reaction differences using by flux analysis results. Fifth steps, calculating pathways. 6 steps, statistical significance analysis using by ANOVA. 7th steps, applying PCA and changing dimensionality. 8 steps, classifying healthy or patient individuals using biologistic regression algorithm. We explain data splitting in experimental results section. So I will start scaling reaction by standard scale. At this point, we use scikit-learn library, and we aim to scale our data normal standard to standard normal distribution, and we standard scaler create calculate z-scores of each features and each values, and it aims to standardize our feature distribution of features. And second steps is applying flux analysis such as PFBA and FBA. We aim to analyze different flux analysis methods, how it's affect our classification performance, and how affect our time consumption. So we compare PFBA and FBA methods in our pipelines. After when we calculate flux, we calculate flux values, by using these flux values, we calculate reaction differences. When we calculate reaction differences, we calculate healthy individual mean of flux values from healthy individuals. We call healthy flux mean, and we calculate for each individuals to subtract we calculate for each reactions, and for each individuals we subtract their flux values from their flux values to healthy mean flux value. And after that, we calculate pathways, and at this case, we compare use on the model reaction differences or pathways. So when we create our pipelines, in some case we add calculating pathway step. At some case we don't. After that, we analyze statistical significance of our features. In some case, pathways is our features. In some case, reaction differences are our features. We apply ANOVA statistical analysis, and we compare results. We get top 10 pathways or top 10 reaction differences. So after that, we apply principal component analysis to change dimensionality. We call change dimensionality because principal component we don't dimensionality reduction. We use PCA to change dimensionality. And last at that point, we classify healthy or patient individuals using by logistic regression. We use logistic regression because I say that we based our study based on the metabolytics algorithm, and the metabolytics algorithm says get best results from logistic regression algorithm, best reasonable results from logistic regression algorithm, so we use it. And we calculate a score to compare classification performances. And the experimental results, I talk about our results, and our evaluation metrics. And first of all, I will explain our data set. We have a breast cancer data set. It includes 211 individuals, which are 135 breast cancer patients and 76 healthy individuals. There are 228 reactions, which are base features, and we extract from them 10,600 reaction differences and 98 pathways using by Cobra library. It's a Python library, and we modify it, and we use scikit-learn library to apply standard scalar PCA logistic regression and to create pipeline like something. And we use cross-validation strategy, and at the 5-fold. So we get several results, and when we want to show this result. In this case, we use some box plot graphics, and we when we call the results when we call results, it means average of 5-fold results. And we aim to, in this study, compare flux analysis methods and feature types. So we create 4 different pipelines to evaluate them. First of all, we try to we analyze flux analysis methods, and we use PFBA and FBA as the flux analysis methods. And when we get we compare it according to time consumption and classification performance using by F1 score. So when we compare it according to time consumption, PFBA 2.8 times more efficient technique. We can see at the graphic. And when we compare according to classification performance, it's using by pathways. We can see that nearly equal score. So we cannot decide methods according to classification performance, but we can select PFBA according to time consumption at this case. After the flux type analysis, we analyze feature type using feature types, how it affect our model. At this point, we use as a feature one of reaction differences, and second one pathways. We can see at the table best top 10 reaction differences and F scores and P values for FBA methods, and we can see reaction differences with FBA methods and top 10 reaction differences. And also we can see PFBA methods and pathways, top 10 pathways with F score and P values, and also with FBA method. After the review them, we create 4 pipelines, and we evaluate them, and we get some F1 scores. At this case, we can see that reaction differences is best feature types, better feature types according to better feature types than pathways. You can see that, and we say that PFBA and FBA also need equal and so close classification performance, but in this case FBA has better performance little bit. So we can, but we know that PFBA has a much more timely efficient. So still we can use PFBA, we think, and conclude that we use metabolic networks, and we analyze flux type, flux analysis methods, and we analyze feature types for our classification model, and we compare them. We can say that PFBA is a very time consumption methods according to FBA, and reaction differences has reaction differences affect better affect well our classification model. And thank you for listening.